Hi, good morning, my dear students. Yes, last class, yesterday, we have discussed very important concept, examples of the subgroup and group. So already you know that, what do you mean by group? Group exists for the 4 to 5 axioms: closure, commutative, associative, identity, and inverse. In that way, we are going to another very most important concept, subgroup. So yesterday, so many examples we have solved. So it means they are going to clearly which one is a subgroup and which one is not, like that we are expressing. In this one, we are already studied in the first year set theory. What do you mean by set? Well-defined collections of objects. Well-defined collections of objects. It means group. Like that. What do you mean by subset? Subset means if every element of A is also element of B. So we are consider one biggest set B is there. It means I can take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 numbers are there. In that 10 numbers I can take one element or 2 element or 3 element. So these are known as called the subset. So here also, I hope another definition is there in the first year. So power set, collections of all subset. So here also, we are considered express for the binary operation and group. So already you know that G be a biggest group with binary operation, and H is the subgroup of element with operations of the binary value. So on this one, we are going to defining let G be a group and H be a subgroup of the binary operation. So in that same, under the condition, it satisfies all the things. So that is known as the subgroup. So in this one, we are going to express for the most important concept. So already you know that subgroup. Let G be a group under binary operation star and H be a non-empty set, non-empty subset. If every element of G is also element of H, every element, that means it involved, it is a part, it is a portion. So that is we are going to say that. So a subgroup of Z, if H is a subgroup itself under the same binary operation. So that is very clear definitions they have given. You try to understand where G is there. In that G, some element. We are picking the elements. So that is called the H is there. It is a non-empty subset. So that is most important value. In that another one, already you know that simply every set is a subset itself. Every set is a subset itself. Every set is a subset itself. So then only if G is a subgroup, then Z itself a subgroup. So clearly try to understand. So each and every element, where you have studied in the first year, already I told to you. So what do you mean by proper set? What do you mean by improper set? Right? So today try to understand. Go to take our first year textbook in the first year chapter. It is a very linkage between these two concepts. So that's why please try to understand what do you mean by a group, what do you mean by subgroup. In this group, every element. So I'm one of the person is there. I'm subset myself. So that is called the Z. Z is every element itself a subset. So one biggest set is there. In that biggest set, we are going to deal with. Every set is a subset itself. Therefore, G is a group. G itself is a group of Z. G itself is a group of G. So then only we are going to consider. Most important, a subset consisting identity element alone. Every subset, it's a most important identity element. So I hope what is the identity of addition? Identity of addition is 0. What is the identity of multiplication? It is a 1. Right? So like that, in that identity, in the binary operation, we are consider E. So here that subset consisting of identity element alone. So that is E will be always a subgroup of every element of Z. So keep in your mind, E will be always a subgroup of Z because it is the biggest identity element. So these two subgroups, one is the identity, another one is the, so we have considered every element. These two sets are known as the trivial. In the second layer also, empty and some other group. So that is called trivial. So then only I can say that improper subgroup. It means something we are having element. So in this one, we have another biggest theory, means expression. If there is any other subgroup of Z except the group itself. So we have considered one small thing in this expression. When you can consider Z except for the other elements, you are going to deal with here. So there is any other subgroup of Z except, right? Except, it means they are edited. It means another group. The group itself and group containing identity element alone is called the proper subgroup. We are another type of group. Most important for the subgroup. So those are most examples are there. I hope you know that complex number is very important. It is one of the kind of subset in this one. So I hope you know that it is a real number. Complex number is the biggest set. Look at R plus is the subgroup of C. This is the values. So in this one. So like that. Q plus is the subgroup of R plus. Right? So in the clear picture, look at this one. N plus is not a subgroup. Why N plus is not a subgroup? Does not having for the any identity element in addition of natural number. So this means you can take here W, yes, exists. But what about universe? Universe is also not exist. So even though you can take, it means integers, the possibilities are there. So that's why we think about this one. And the fourth example is most important. So this one, Taylor diagram to express for the ideas in that one. So here 1 minus 1 minus I plus I is a subgroup of this one. So here these are the another type and most valuable answers are there in this expression. So group and subgroup and example, proper, improper, trivial groups are there. So these are the most important. So we are going to study all the concepts. So next I am going to discuss in your next class, postulates and axioms are there, theorems are there on this page. I will continue. Most important, please try to understand. I will define you for the another few things in the next video. Thank you so much.